Starting off with question 14, it's going to ask us to go to our testing data and copy the chart and actually paste it in here, for example, underneath our proportional limit stress. Okay, so I'm going to go to the SSA software, and what you'll need to do is you actually need to open up your file through the SSA software. So open up the software, go up to File or Open, find your file, hit Open, and then you'll have a chart that'll pop open like this. Before you maximize this, what we're going to do is go ahead and grab a screenshot of this. So you can go into using your Snipping Tool, or you could very easily just use print screen and then copy and paste that into the document. I'm going to go ahead and go into the Snipping Tool. And I'm going to make sure I grab the entire box there that has this information up at the top right here, as well as the bottom all the way. You need all that data. Okay, and we can go up to Edit, Copy, go back to our Word document, and we're going to paste that in there. And what you might want to do here is we can kind of stretch it out. It's all right if it skews it a little bit, but we'll stretch that data out there so that we can see this information. And we don't need this anymore. And then we can go ahead and copy that, and we're going to paste that a couple of more times. Wherever it says the tensile test results graph, all right, let's scroll back up to the top here. All right, so what we need to do here is we need to read this data and figure out what our proportional limit stress is. So if we just look at this graph, it's kind of hard for us to tell exactly what the data point is. So you're still going to have to go back and forth between the SSA program and this chart. All right. From what you learned, you should know that the proportional limit stress is where proportionality ceases. Past this point, proportionality ceases. And typically, it's somewhere up in here where we start to see it go from a nice straight line here, and then all of a sudden it curves off and goes flat. So I'm going to guess it's somewhere around 750 to 800 in that neighborhood. Okay. I'm going to go back to the SSA software, and what I can do here is maximize this so I can actually see the chart a little bit better. So I'm guessing again somewhere in this neighborhood, 750, 800. On the left-hand side here, I'm going to click on Show Data. This is going to give us our data points. It's going to help us to see exactly what the measurements are. The left column here is in thousandths of an inch. It's measuring deformation. The right column is in pounds. It's measuring how much force is applied. So I'm going to scroll down until I see about 750, and then I'm going to start to look at the data. So you can see here 721 to 743 is approximately 20, to 64 is 20, another 20 is added. We're getting close to 20 here, a little bit less now. And you can see as we go from 764 to 782 to 797, I've dropped from 20 to about 15. Then when I go from 797 to 808, now I'm looking at about 11. So you can see that we've all of a sudden stopped adding 20 pounds and stretching a thousandth of an inch, but we now add 15 pounds and it stretches a thousandth of an inch. So that's where our proportionality ceases. And that's going to be what we're going to choose as our proportional limit. So I'm going to choose this one right here, because it goes 20 pounds, 20 pounds, 20 pounds, and all of a sudden drops down here to 15. So I'm going to choose 782 pounds, and it's going to be 42 thousandth of an inch. Okay. So if I go back to here, my formula here is stress is equal to force over area. Okay. So then my force is, if I go back to my data, 782 pounds. So 782 divided by my area, and that's the original cross-section area. We're going to use that for all of these calculations. And for me, that was 0.123. And if I 782 divided by 0.0123, I get approximately 63,577. And make sure to include your comma so that it's easy for me to check. And that's actually going to be in pounds per square inch. Okay. We're going to scroll down. We're going to look for our yield point stress. And a very easy way for us to identify this yield point stress is just to say if this is my proportional limit, my yield point is just going to be the very next point. Okay, so I'm going to use 797 and at 43 thousandths of an inch. So you'll notice the equation is exactly the same, but the force changes. So it's 797 divided by, again, our original cross-section area, and we get